Welcome to Champlain Maker Fair's renewed culture of innovation, Makers on Screen. I'm your host, Doug Webster, and today's show is Drones as Tools, AirShark Startup. The maker movement has inspired us to pursue design, development, and production of new, exciting open source products. Making brings us together with tools and desire to improve the world around us. Since Champlain Maker Fair began in 2012, there has been a burst of interest in making, maker spaces, and learning with new tools. My guest today is Ian Ray, co-founder of AirShark, a startup that makes and uses drones in engineering projects. Welcome to the show, Ian.
Thanks for having me, Doug.
Great. Well, so Ian, tell us about AirShark.
Sure. So AirShark is a business that myself and two other co-founders have started focusing on using drones for industrial inspections. So a variety of things that are kind of hard to get to and look at.
Yep. Yeah. Now, what makes AirShark unique?
That's kind of the great thing about what we're looking at is that the majority of the drone industry right now is focused either on consumer uses, hobby, carrying a GoPro around for entertainment, or for commercial agriculture, so looking at farms and things like that. We're focused on a different segment that not a lot of people are paying attention to, and that's the commercial inspection area. So for us, any place that someone has to get in a harness and go and look at something like a wind turbine or a bridge, is something that we can look at with a drone that's very difficult, hazardous and or expensive to do today.
Well, we'll take a look at that in a little bit, but let's back up a little bit too.
Sure.
As far as when you started AirShark, what were some of the challenges you had in starting the whole process?
Well, getting the funny thing is, anytime you talk about drones, starting a business is a startup or getting off the ground. So there's always a pun in there somewhere.
Right.
But getting the business up and running has really been a challenge because we're building a market. If you go out to build an iPhone app for a certain niche, there's already kind of a precedent on how you do that. In drones, with the combination of regulations that are still developing, and also just customer education, we're kind of building the knowledge of the market need ourselves, and kind of through the industry.
So you're, in a way, creating demand and educating people along the way.
Exactly.
Yeah. So as far as drones go, how did you get interested in drones in the beginning?
I kind of fell headfirst into it. I've worked in commercial photography and in building commercial photography tools for a number of years. And I started looking and saying, well, cameras that can fly, that's like the future of, or one of the futures of photography. And so I started looking into, well, what does that take? Okay, you take a couple of motors, you put them together, and after about 100 more steps that I'm not going to list, you get a drone. So that's kind of how I fell in, like I said, fell into it almost. Yeah,
right. Now, we all know that drone use can be somewhat controversial these days, and it seems to be getting more and more attention. How do you, what's your experience, and how do you navigate through that?
It's been really interesting for us because there are a number of concerns. Obviously, privacy is a major concern. And a few weeks ago, a drone smaller than this accidentally ended up on the lawn of the White House, which is obviously a concern. But in Vermont, we found that people have been very receptive to the drone technology, and I think that's because in Vermont the community is a little bit more receptive to the applications that are available. We're kind of focused on renewable energy, and there's a lot of applications in that field that we can do with this. So as soon as you start talking about the positive uses as opposed to the possible nefarious uses, I find the conversation gets a lot more interesting and positive.
Sure. Now, we had a chat a couple of weeks ago, and during that time you were reviewing the latest drone use rules. I think it was the FAA that put those out. Can you tell us a little bit about that and what some of the changes were? What are some of the limitations and so forth?
So the drone regulatory environment has been quite a gray area for commercial use up until new rules were proposed actually on Valentine's Day or on the day after. And the new rules outline actually a fairly permissive set of rules for how the drones can be used in a commercial context. So there are some limitations on flight altitude. You're limited to 500 feet off the ground, and you're limited to flying within line of sight. So for some of the applications, like we talked about agriculture and things like the Amazon delivery drones, those are kind of out right now. But for us, for inspections that are closer in, the actually new proposed rules have actually been very good and allow for exactly what we're looking to do.
Oh, that's great. That's great. So can you tell us, what does your drone do?
Sure. So at the top level, the drone carries cameras. And the interesting part is what cameras it carries. So right now, our platforms can either do high definition still and video, which allows for a lot of different inspections. And we also have thermal cameras that can see heat. So if there's a leak on a roof or a power line that's failing, if you look at that with a thermal camera, you'll see a failure actually before it happens. And as you take that information and kind of put it into the hands of people that can actually do analysis, that's where a lot of value is created for the different kind of market segments.
Now, can we zoom in on this drone right here we have in front of us? Here, do you want to describe what this is all about here? Well, different parts and so forth?
Sure. So, like I said, at a top level, the cameras are the most important part of the system. And so that's where this camera gimbal, which actually stabilizes the cameras, comes into play. So that's kind of free moving, and I can move the cameras around and actually control them from the ground, point them up and down where I need them to be. Obviously, it's run by propellers, and this unit runs off of is called a quadcopter. So it has 4 motors that balance it in the different directions. You change the speed, and you've kind of rolled it back and forth. And the beauty of it is it's run off of a flight control system that's open source. So the sensors that make this possible are all in this little box right here, and kind of at the conceptual level, it's somewhat similar to your phone, in that the same sensors you use to play, a racing game on your phone, are also telling us what angle the quadcopter's at. Also has GPS, which is this little stick right there, and that allows it to be autonomous if we need it to be. So I can tell it to fly from point A to point B, or even fly to point C and land itself. Which is also a great safety feature. So if we lose the radio communications, it comes back, lands itself completely on its own.
Oh, nice. Now, what is the range of this, height and distance?
The range of it is actually farther than we're allowed to go with it. So the radio link should be good for, in open air, would be about a mile. In a more dense area, you'll get a little bit less range than that. And vertically, it can go quite a bit higher than the limitations of 400 or 500 feet.
Okay.
So for our inspection purposes, the range is more than sufficient.
All right. We've got a couple of pictures to show. Let's take a look at a couple shots.
So this is an image of a construction site that we took a look at. They were diverting the river actually around some contamination in the sediment. So they were actually digging up the half the river at a time, and we went out and did a number of images for their communications department.
And here's another one.
And this is another kind of a hero shot for a customer that installed a solar array. So this image kind of gives you an idea of the perspectives you can get, and that's taken at about maybe 150 feet, 200 feet off the ground. So when the limitation is 400 feet, or as the new rules say, 500 feet, we've got plenty of headroom to do, almost any kind of inspection you would need to do.
Sure, sure. Okay, so we have a video that we're going to show. You want to talk about that?
Sure, yeah, I can lead it in a little bit. The video that we've got is a 3D model that we generated of the high school in Montpelier. And it's generated by taking a number of still images, combining them together, and basically inferring a 3D model out of it. So you'll see it in the video. But the beauty of that is it's a model you can gather measurements off of. So if we need to put something on the roof, I can say the roof is, that section is 50 feet long.
Okay, okay. All right, well, let's roll that clip. We didn't want to talk over that with the great music there.
Yeah.
So can you describe a little bit more about that? And you said measurements. How do you do the measurement aspect?
So the model that comes out of it is a 3D piece of data that you can import into standard CAD packages. So someone who's a building inspector can just load that into their software package, and they have a point in time 3D reference of what the site looks like today. So you can do things like check against, is the building today in the same, has the building moved, has something shifted, via those kind of industry standard packages.
Okay. Cool.
One of the things we're working on with that model right now is there's a few places where it doesn't handle some of the skinny features, like the smokestack. And so we're working on increasing the resolution so that it gets a little bit smoother and the measurements get even more precise.
And how would you do that, the increase of resolution? Is it drone related or is it software related, or which?
That's actually changing the camera processing that we're using.
Yeah.
So we're using a camera that has a bit of a fisheye to it right now. And so moving to a different camera that has a slightly different lens on it is kind of the first step.
So if you did that, you'd have to be further away, correct, to get the same effect?
A little bit, but not too much.
Too much.
Not too much. Yeah.
Not above 500 feet.
Not even close.
Yeah.
Yeah.
All right. Well, now you are a member of Makerspace.
I am.
Yeah.
And so about a year ago, right when the space had opened, I joined the Generator Makerspace, which is here in Burlington. And that's given us access to a lot of different tools that we have used to build some of the prototypes. When you look at this platform, actually anything that's in this kind of a tan color came off of the 3D printer at Generator. And so that's kind of allowed us to prototype these platforms much faster than it would if I had to call up a 3D printing company and wait 2 weeks for the part to arrive.
Right, right.
I can turn around and usually have them in a few hours, if not overnight.
Excellent. Excellent. So what else about the Makerspace is important to you? I mean, you rent a studio.
Yep.
You use other equipment as well. And would you, if you were not in that Makerspace, how difficult would it be for you?
It would be. It would be more difficult, and really the key part of that is just having face-to-face conversations with people who know what they're doing in very technical fields. For example, I don't have a background in CNCs and in machining parts, but through the Makerspace there are people who do and are willing to share their time.
Right.
So if you have directed questions, you can get a lot of information much faster than, I guess the alternative would be me Googling and, buying my own CNC and the difficulty that would come out of doing it myself.
Yeah, so collaboration, tools, and a place
exactly
to do that.
And having the space to do the work.
Yeah, that's great. What was your experience in high school and other, what did you do then that helped you do what you're doing today?
The honest answer is almost nothing. And that's kind of the thing that I find really interesting when I get asked that question, is that I trained to be a photographer. I went through high school and then got a bachelor's in photography. And for the longest time I thought I was going to be either a photojournalist or a commercial photographer. Fell into building the tools that photographers make instead. I made radios for the photography industry. And kind of through osmosis and through working in product development there, learned a little bit about hardware manufacturing, a little bit about electronics, and kind of just started to put together a skill set that eventually gave me enough knowledge to start building the drones. So I kind of, anytime I get asked the question, I always try not to refer to myself as an engineer, because there are people that train very specifically to be engineers. But it's been really interesting to just kind of almost through osmosis pick up the little bits and pieces that are required to be a jack of all trades, I guess.
Yeah. So is there anything you wish you had done differently during that time?
I mean, I wish there were 36 hours in a day. But
me too.
In terms of actually prototyping and kind of building the startup, I will say that I wish I had a little bit more experience in the engineering disciplines, and that's traditionally been very difficult to get that kind of experience, especially at the high school level or even going into college. And so that's kind of the beauty of the makerspace and of generators, that one of the great things about building these is that I'm building the cool thing. So we get a lot of students that come through the space and are asking like, "Hey man, what's that?" So we get to talk about the drones, and there are kids that are 13 and 14 are saying, "Oh yeah, I've got my drone that I built myself." And I'm like, "Yes."
Yes. Now, what are the different types of drones that you build, and what types are out there? Sure. Can you describe the different?
So the drones that we build are focused on being a little bit more rugged for the commercial and industrial customer. A lot of the drones that are out there right now are built to kind of hit the magic $999 price point. And so there are some compromises made there to get them under that price point in terms of quality of the hardware and the electronics. There's some great platforms out there, but not something that's going to go in the back of a power company's truck every day. So, and that's kind of what we're focusing on.
Right. Now, you have a quadcopter, there's hexcopters, octocopters, or how do you say that? But,
yeah, I guess the way to break it down is that there's multi-rotors, and then there are airplanes. So there are drones that look very similar to a normal airplane and that fly just like it. And then there's the multi-rotors that are based solely on lift from fixed pitch propellers. And you'll see quadcopters and hexacopters and octocopters that really just have different numbers of props. And the more props you add, the more weight you can carry effectively. It also helps with efficiency a little bit.
Is it more stable?
Only if a motor fails is really where it gets important. So if you have 8 rotors and one goes down, you're not going to be tumbling out of the sky, in theory. So that's kind of one of the reasons that as the amount of as either the weight or the value of what you're carrying goes up, you'll see kind of the number of propellers multiply as well.
Okay, great. Is there anything else you wanted to add about your drone?
No, I think that kind of covers what we're working on. Well, I guess I will add that we're building both the hardware right now,
Yeah.
and we're focused on eventually developing the software tools to manage the information that
Yep.
comes off the
Okay.
platforms. Because really, at the end of the day, the data is the value,
Yeah.
and not necessarily just having the drone itself.
Now, what's in store for AirShark in the future? You have some new designs?
Yeah,
wanna show it?
and that's kind of where our next platform comes in.
Yeah.
So the unit that we have in front of us is got wires running all over the place. It's the perfect prototype in a lot of ways. And what we're working on is taking that and transforming it into the rugged platform that will stand up to higher winds and and weather. So when it's windy and rainy, things like that, our next platform will actually be able to.
All right. I
operate
think
in
we
that.
have a picture of that, don't we?
I think we do.
Let's take a look at that.
Yep. And so this is a fully weatherized package. And this is a rendering of our design that's in CAD right now. And that will, like I said, shed water, shed dust, and be something that goes in Pelican case and is ready to go at a moment's notice.
It looks kind of stealthy.
It has a little bit of the stealthy look to it, but when it's in the air, it's actually kind of loud. So it's not as stealthy as you'd as you'd think.
Yep. Okay. Okay. Good.
Which, for a lot of reasons, is a good thing.
Yep. Well, great. Well, thank you so much for being on the show, Ian.
Absolutely.
I appreciate you coming out.
Absolutely.
Okay. Great. Today's show was Drones as Tools, AirShark Startup, and our guest today is Ian Ray, co-founder of AirShark. For more information about this show, related internet links, and other shows in this series, go to retn.org and look for Makers. Also, for more information on drones and what drones can do, go to airshark.io. That's .io.
.io, yep, we
Okay,
can put output.
great. Thank you for joining us.